All right. So today we're going to be talking about 10.3 and 10.4. So again, how people can use fresh water to be more sustainable, and then how people can reduce water pollution. Okay. So again, 10.3 is going to be shorter than 10.4 just because, again, we talk about sustainability a lot already going into this lesson. But again, there are different ways that we can be efficient with, again, not using as much water. We have gravity flow. So instead of pulling water from different places just to grow food or, water our crops, again, we use gravity to allow for different ways for the water to enter that area. We have drip irrigation. So again, we have pipes that deliver water to the individual roots. So again, we're not watering the whole field, but we're being very strategic as to where we are placing the water. And then the center pivot. So again, we can rotate where the water is going. And again, we're not watering the whole field, but we're being, again, very strategic as to where the water is going. Reducing freshwater losses in industries and homes. So industries need to intensify efforts to recycle the water they use. So again, this can be any type of gray water. We'll talk about gray water in a little bit. But again, how can we recycle the water that, again, we may not be able to drink, but again, what water can we reuse in those industries? And then in the U.S., toilet flushing is the single largest use of domestic fresh water. I know every time that I use the bathroom, I flush the toilet. That's about 1.6 gallons per flush. So again, we can install low flow toilets, shower heads, faucets. The saying is, if it's yellow, let it mellow, but if it's brown, flush it down. So again, keep that in mind. We could fix water leaks, use loading washers. So again, both of those will allow for less water to be used. Obviously, if there is a water leak, then again, that drop is water usage, okay? And then gray water would be any type of waste after, let's say, washing the dishes, doing the laundry, and all that. Again, you can't reintroduce it into a population or to a river because that would pollute the waters, but you could use that gray water to water your lawn, to water your garden, because the nutrients will be good for that lawn, for that garden, but you don't want to reintroduce it into the river because those pollutants won't be good for the river, okay? Why we need to fix the small leaks? Well, faucet leaking 1 drop per second can drip about 3,000 gallons down the drain in a year. So again, even water you're not even using, 3,000 gallons, okay? And this would be enough to fill about 80 bathtubs. Gray water. So again, gray water is any type of water that is used after some type of household use. So washing the dishes, taking a shower, doing the laundry, all these different things. That would be waste. So it couldn't cause pollution if you do reintroduce it back into a freshwater environment, so lake, river, and all that. But again, you can use that gray water to water your lawn, irrigate your non-food crops, clean equipment, all these different things. And if you can store about half or 75% of the gray water into a holding tank. Again, gray water is not something that has feces in it or any type of body excrement. So again, you don't want the diseases that could be from, again, feces or any type of bodily substance. You don't want that. Again, anything from dishes or washing dishes, faucet use, showers, and all that, the gray water can be efficient that way. All right, 10.4. How can people reduce water pollution? So the best way to reduce water pollution is to prevent it. Okay, so in streams, lake, reservoirs, groundwater, water pollution, this is the water quality changes that harm living organisms or make water unfit for drinking, irrigation, recreation. All right, so the first thing we would need to do is to figure out some type of point sources. So again, specific identifiable locations in which we are polluting that area. That is the main cause. If we don't know, we will just have to diffuse the area with non-point sources, so we don't know exactly where the pollution is coming from. This is hard to find, difficult to identify, control, and expensive to manage because you are covering a larger area. And then the leading causes of water pollution are agriculture, again, with runoff with fertilizer, industrial facilities, and with mining. Again, unneeded minerals or substances going into the water. Stream and river pollution. Flowing streams and rivers use a combination of dilution and bacterial biodegradation to naturally eliminate waste. So again, there are natural factors that cause for different pollution to go away. However, this does not work when overloaded with pollutants, so historically from industrial wastewater discharge, or when flow is reduced by drought, damming, or diversion. So bacterial decomposition depletes dissolved oxygen, eliminates populations of high oxygen using organisms until the stream is cleansed. Lake and reservoir pollution. So lakes and reservoirs have low flow rates and are less effective at self-cleaning as they typically have stratified layers. So near urban and agriculture areas, chemical runoff causes nutrient enrichment of lakes and the mouth of rivers. So this would be called cultural eutrophication. Nutrient overload produces algal bacterial overgrowth. Again, that's taking the oxygen away in the lake. So again, this will kill off fish and marine organisms in bottom waters or dead zones. Groundwater pollution. So groundwater cannot cleanse itself of degradable waste as quickly as flowing surface water can. So this can take thousands of years for polluted groundwater to cleanse itself of slowly degradable waste. Groundwater has low concentrations of dissolved oxygen and smaller populations of decomposing bacteria. Cold temperatures reduce chemical reaction rates. So, again, when it comes to groundwater pollution, this would take the longest of all the water that we see. And again, we would get pollution from spills from factories, water pumping wells, landfills can seep into aquifers or underground groundwater. Polluted air can cause for waters to be polluted too from precipitation. Fertilizers and pesticides can run off into lakes. Coal, strip mining, and all that material and mineral can flow into lakes and rivers and also. All right, so groundwater pollution solutions. So some preventative stuff, find substances for toxic chemicals or substitutes. Keep toxic chemicals out of the environment. Require leak detectors on underground tanks, ban hazardous waste disposals in landfills and injection wells, store harmful liquids in above ground tanks with leak detection and collection systems, clean up, pump to surface clean, and return to aquifer. Again, this is expensive, but again, if you need to clean it up, it is a nice way of doing it. Inject microorganisms to clean up contamination. Again, less expensive, but still costly. Or you could pump nanoparticles of inorganic compounds to remove pollutants. And this is still being developed. Again, this isn't a sure solution, but it is a possible solution and will probably be more refined in the future. Ocean pollution. Many people treat the ocean as a dumping site. So 80% of marine pollution originates on land. So 80 to 90% of municipal sewage from coastal areas of less developed countries is dumped into the ocean. So without any treatment, again, that would be garbage. Anything that could be recycled, all that trash is going to flow into the ocean. Household sewage treatment. So rural and suburban areas in the United States usually discharge household sewage to a septic tank where bacteria help to decompose waste. Partially treated wastewater ends up in gravel or crushed stone deposits below the soil surface. Water percolates down through the gravel and the soil filters out potential pollutants and decomposes biodegradable materials. Sewage treatment plants. These plants waterborne waste in urban areas from homes, businesses, and storm runoff flow through pipes to sewage treatment plants. The primary sewage treatment, a physical mechanical process. Secondary sewage treatment, a biological process. So again, the idea is to take the pollutants and waste out of the water so it can be recycled back in. So a combination removes 95 to 97% organic waste, 70% toxic metals, 70% phosphorus, and 50% nitrogen. But again, it will not kill viruses, bacteria, disease-causing agents before a discharge undergoes chlorination. So again, it's the cleaning of this water. That is it for 10.4 and 10.3. Please watch this again if you have not gotten the notes for it.